Salts. So salt is a product of a titration reaction. So it's any ionic compound that results from a titration of an Arrhenius acid and an Arrhenius base. Salts, when they're placed in water, can also affect the pH, so I can treat it like a net ionic equation. So let's say that I have sodium fluoride and water. Sodium fluoride is a salt because it has a cation and an anion. Sodium fluoride and water. So I can look at these as a net ionic equation, assuming that these are all ions, right? And that creates HF and sodium and hydroxide ions, right? So sodium fluoride will dissociate completely because I have an alkali metal. H2O won't, but we're pretending that it does. But what happens is when sodium ion bumps into fluoride ion, it will dissociate again. But when a sodium ion bumps into a hydroxide ion, it will also dissociate completely. So sodium always stays in solution. However, when the F- ion bumps into H+, every now and again it will actually stay stuck to the H+, creating HF. Right? Fluorine is a strong anion, and so when the fluoride ion grabs a hold of and bumps into H+, it will stick to that H+. And as a result, I will have excess hydroxide ions floating around because some of the H pluses are now being stuck to fluoride ions. My concentration, even though I came in with an equal number of H plus and OH minus ions, now I have an imbalance. I have more hydroxide ions than hydrogen ions. So as a result, I have a basic solution. Because of its effect, we call sodium fluoride a basic salt, because when it's placed in water, it causes the pH to rise. And that's because it basically rips apart water and sticks to the hydrogen ions. But the hydroxide ions don't stick to sodium. So a weak cation and a strong anion result in a basic salt. Right? Sodium is a weak cation. It can't stick to anything. Strong cation with a weak anion result in an acidic salt, and if they're equal strength, it will be a neutral salt. So whatever the cation and anion strength are, whichever is stronger, that's the type of solution it will result in. You can also think of salts as being acidic or basic by the fact that they are the result of a titration reaction. So sodium fluoride again. Sodium fluoride is a result of sodium hydroxide being combined with hydrofluoric acid. I'm simply taking the cation and I'm adding it to hydroxide. And I have the anion and I'm adding it to the H plus ion to find out what base and acid they came from. Sodium hydroxide is from your list of strong bases. HF is not from your list of strong acids, so it must be weak. So this dissociates completely. I have maximum hydroxide ions at titration, but this does not dissociate completely, so I have less than maximum hydrogen ion concentrations at titration. So at the titration point, I will have an excess, or I will have more hydroxide ions than I will have hydrogen ions. That's a basic solution. So again, sodium fluoride is a basic salt. So if you're looking at it in terms of the result of a titration reaction, a strong acid with a weak base will result in an acidic salt. A strong acid with a strong base will result in a neutral salt, and a weak acid plus a strong base results in a basic salt. So you can look at the pH of a salt, labeling it as acidic, basic, or neutral, by either thinking of it in a net ionic equation reaction and seeing what sticks to what part of water, or you can think of it as the result of a titration reaction where I'm putting acids and bases and I may not have at the end an equal concentration of hydroxide with hydrogen ions. Either way, you'll end up with the same answer as to whether the salt is acidic, basic, or neutral.